Hi, I'm Bill Millar, and I'm here with Levi Strawn and Zach Mosley, and today we're going to cover our project proposal. First, we'll go over the problem definition statement along with the requirements, and then we'll get into our designs by instrument type, and finally we'll summarize with the three instruments that we're going to create. So for our problem definition statement, we came up with to design and construct three instruments to play the song Alma Mater. The first requirement is that all three plus one counted twice must fit inside of a 2 foot by 2 foot by 2 foot box. Each instrument must cost $15 or less to create. Each instrument must play its correct notes, and the three instruments must use less than 8 feet of pipe and 4 feet of piano or guitar wire. Our top three design considerations were: 1, the size of the instrument, 2, cost to produce, and 3 was the quality of tones. So now I'd like to turn it over to Levi, who will go over our string instruments.
Hi, I'm Levi Strawn. I'm here to go over my string instrument design. The dimensions are 60 centimeter overall length for the body with a 5 centimeter squared neck and a 25.4 by 10 centimeter resonance chamber, solid beam construction, and a string through body design for improved sustain, easily detached resonance chamber for storage, repair, or travel, steel frets, and machine tuners. Attached is a detailed diagram of my fret modeling. I've included our decision matrix for the stringed instrument. It covers the criteria and the corresponding weight for it, and our voting record. In this slide, we're going to go over the design physics for string 1, D3. I provide you with steel density, your length, and your frequency for D3. Calculations for mu, tension, and I also provide an array for frequencies, and then also a calculation for string length by frequency. That is how I'm able to provide the information in the box. This slide covers the design physics for string 2, C4. Steel density is the same, length is the same, and our frequency is changed. So therefore, our mu is changed, tension is changed, frequency array is changed, and the answers produced by our string length by frequency formula is changed as well. It's all showcased in this box. This slide showcases two similar but different approaches to the same problem of designing a two-stringed instrument. One has a very traditional body shape to it, and the other one's very minimalist.
Thank you, Levi. So the percussion instrument that our group chose to go with was my design, which features an 1/8 of an inch cantilevered steel bars inside of a pine wood frame. It comes with 2 foldable legs on each side. It plays the low notes in Alma Mater, and it's approximately 8.5 by 18.35 by 1.6 inches. So the way that we chose this design was that we had 2 other designs by Levi and Zach, and we voted, and it turned out that mine ranked the highest out of all of our criteria. So some designs that are similar to my design are the concert bells, which feature steel bars played by hitting it with a mallet. And another one is the umbira, which is a cantilevered metal bar instrument played by striking it with your finger. So the basics behind my design are that For the low notes, I determined the frequency for each note, and then I used the equation on the right-hand side to determine the length of the steel bars for the instrument.
Hello, my name is Zach Mosley, and this is the wind instrument we will be going with. We chose this instrument based on devoted criteria, which we gave weights to. My design scored the highest. The other options that we had for our wind design were going to be a pan flute by Bill, a preliminary design of a pan flute by myself with some holes to change the tone of the notes, and a steel tube design for Levi's. The features of my pan flute is going to be a 9-pipe pan flute with a high voice of alma mater. It's going to be about 10 to 11 inches long. It's going to be 9 inches wide, and then it's going to be 2 inches thick, all in all. It's going to have clay stops to tune the pipes. It's going to have a curved design to kind of improve the ergonomics and looks. And I'm going to secure it all together some hot glue. This is here we have some other examples of pan flutes. We have a very modern looking pan flute on the left, and on the right we have a more older European style. So my calculations of the lengths and how I came to this design. So we have to solve for the length with a pipe with one opening is the equations here. And we must remember to subtract 61% of that inner radius, otherwise we'll end up with a flat pipe. And here we can see the lengths of the pipe and the corresponding frequencies and notes. So in the end, we have chosen my PVC pan flute for the high voice, the 2-string guitar for Levi for the middle 2 voices, and Bill's steel bar xylophone for the low voice. Our next steps will include purchasing and gathering materials, construction of the instrument, and testing and any alterations or iterations that need to happen. Finally, we'll record the song, put it all together, and we'll be done. So thank you guys for watching, and you have a wonderful day.